Good morning. I am delighted. The room seems pretty full. I know it's early and it went a little late last night, but did you have a good time? Who played Galaga? Only a few. Paperboy? There was Paperboy. You guys, you have no idea how great this is. Okay. It was an outstanding party, and thanks for being there. Now, some reminders. Of course, the mobile app, keep rating sessions. I can't say it enough. We're getting great feedback. Keep it up today. Keep posting pictures, posting statuses. Have a good time in there. So keep after that mobile app. Keep tweeting. I've seen lots of great tweets. I think this morning we could see even more. So keep it up. The Kafka Summit hashtag is where you want to be. Now, with that, I don't have too much to say this morning, other than I get to welcome to the stage co-founder and CTO of Confluent, co-creator of Apache Kafka, Neha Narkidi. Neha, welcome to the stage.
I'm really excited to be here for our very first European Summit. There were so many good stories I heard yesterday. I hope you all are looking forward to another day full of all things Kafka. You heard Jay speak yesterday about the event-driven architecture, about the stream and table duality. In this talk, I want to focus on the present and future of the streaming platform in an enterprise. I want to take you through the streaming adoption journey, all the phases that an organization needs to go through in order to become truly event-driven. Along the way, I will also share some customer user stories to make this journey real. Okay, so let's get started. Before we look into the journey, let's first look at this pre-streaming world. The pre-streaming world is complex. Data is stuck in legacy systems in various silos. Data moves around in bespoke batches and hence is also processed in a batch fashion. And then there are lots of these point-to-point connections that make the whole data architecture pretty brittle and lossy. Essentially, in this pre-streaming world, the focus and all the time is spent on data plumbing. But that is all the focus and time taken away from building event-driven applications that really drive the business forward. And this isn't just about a move from batch to real time. I really want to focus on the agility aspect of things, how quickly we all as developers can evolve our applications. As you can see here, in the traditional request-response application architecture, there is a tight temporal coupling between the requesting service and all the downstream services that have to respond to that request. This works. This is deterministic. But it is quite rigid. There's a lot of tight coupling between the services. As you try to break your monolith and move to introducing many more services, this also starts to get operationally challenging. So if you compare and contrast this to event-driven applications, instead of synchronously calling into each and every downstream service, this is really different. The application publishes a fact as an event, and then all the downstream services could react to that event and process that event differently. Essentially, the requester does not immutably dictate all the downstream processing. It passes that control over to the event handlers. Why? Because the core belief is that the action can be determined at runtime. It can change depending on the changing business context. As a result of that, event-driven applications, they're much more loosely coupled. These services on the right, they can change, they can come and go, and it does not affect any of the rest of the applications. So how do you move from the pre-streaming world to the event-driven one, and what impact does it have on your applications? It doesn't mean that you necessarily rip out all your request-response applications and put in event-driven ones all of a sudden. But it is much more about significantly supplementing it wherever it makes sense. So your transactions might still be done using synchronous request response applications. They're deterministic. But then all the downstream processing that needs to respond to that request could be done using event-driven applications. So what's needed to make this transition and this journey to being an event-driven enterprise? It isn't just about adopting a different technology. It is much more about changing the way you think about business and how your data drives your business. It's about making a fundamental shift to event-centric thinking, as you heard in yesterday's talk as well, about continuously sensing, assessing, responding to streams of events that matter to the business. You, of course, do need the technology that drives this, that enables event-centric thinking at an organization-wide scale. In fact, that was a very core motivation we had when we built Kafka, is to enable event-centric thinking everywhere. You know, one of my favorite examples of an organization that is enabling, that is really changing the way they operate is the Norwegian Work and Welfare Administration. They have an initiative they're proposing. They're calling it Life is a Stream of Events. They're trying to put event thinking into practice for all 5.2 million citizens of Norway. Their vision is to make the government work for citizens proactively versus having the citizens worry about every big life event and all the downstream things that need to fall into place to get relevant benefits. Kafka will be at the heart of this event-driven government. Every life event will trigger a message in Kafka that will then trigger a whole bunch of downstream event-driven applications that will respond to that life event. They will do all sorts of things, reducing welfare crime in real time, all the way to actually pushing the relevant benefits to every citizen. We all know that things don't work this way, so NAV's vision is to be a model for all governments, to apply event-centric thinking for the welfare and happiness of all the citizens in the world. I think this is really inspiring. So what I want to talk about next is how do you begin this journey to being an event-driven enterprise? As you might guess, this isn't a one-step fix. It's a multi-phase adoption journey. Each stage has its own unique set of needs that a streaming platform must fulfill. This journey begins with awareness, like any other journey. In this state, you realize that you have a need for real time. You have a need for event-driven applications. You may have even heard of Kafka being the de facto streaming platform, and then you wonder what a streaming platform really does. Is it faster messaging? Is it better ETL? Is it more real-time Hadoop? And the answer is it that it's a bit of all of the above. There are really three uses of a streaming platform in an enterprise. The first use we're all aware of is using the streaming platform as a modern pub-sub messaging system. Now, if you squint a little, Kafka is an MQ. But it is pretty different from all the other MQs, isn't it? It's built as a distributed system from the ground up, so it is scalable. It persists data so it can truly decouple your applications. And it also acts as a foundation for stream processing, allowing you to reprocess data in order. Not only is the streaming platform used for pub-sub messaging, but it is also a foundation for streaming data pipelines. Take Kafka's Connect API, for example. Today, you can build these streaming data pipelines in a very off-the-shelf manner because there are so many growing ecosystem of connectors available now. The key takeaway is that Kafka Connect does the hard work that is then available to all the connectors. So this platform-driven approach really makes data pipeline simple. So the third use of stream processing, a lot of what this Kafka Summit talks have been talking about is stream processing, right? And there are two ways you can do stream processing in just Kafka itself. There's the Streams API for Java developers who want more control over their code, and then there's KSQL for everyone who wants to do any stream processing. Since we announced it at the last summit and released it, KSQL has been downloaded several thousand times, integrated into analytical tools, has been used to do anomaly detection, streaming ETL, and a whole host of other use cases. I'm hoping that you're as excited as I am now that KSQL is generally available. So all these lenses come together in one technology. It's the streaming platform. Now, once you understand what a streaming platform does, depending on what you're looking to do, whether you're looking for a self-managed solution or not, you might either choose to download something like Confluent Platform or just go look for a hosted service. And whichever route you go, in the first 15-minute experience, you're just looking to explore Kafka. You might use a UI, maybe create topics, maybe send and receive messages. You might want to look inside the topic to see what messages look like. Maybe even run a couple of KSQL queries to generate more streams and tables. Or you might just be looking to check the consumer's lag. What you see here is pretty much what you want to do while building your very first app. On the other hand, you might just be looking for a fully managed Kafka in the public cloud, and then you might choose to sign up for something like Confluent Cloud. This is arguably, possibly the easiest way to get started with Kafka, where all you focus on is building applications, leaving all the aspects of Kafka management and operations to the experts. Okay, so that was just introducing the streaming platform, what you do with it in your first 15-minute experience. What I want to focus on now is then you're ready to take your very first steps into production. This might seem a little familiar. Now, there are only two options broadly to take for the first steps in production. The first one is connecting into data that sits in legacy systems, that sits in external data stores, and then moving it into the streaming platform. And the other option is producing new streams of events. So let me take an example about option one, which I've seen quite commonly here. Nordea, a retail and investment bank in Copenhagen, they faced a problem a couple years ago. They needed to be MiFID II compliant. Now, for those of you who may not be aware of MiFID II compliance, MiFID II compliance is European legislative to increase the transparency and faster reporting in European trades. This means more complete audit trails, faster reporting, and for Nordea, being MiFID II compliant meant breaking down silos to get an aggregated view of all the trade data in the bank. But as a result of that, they needed to handle a lot more data as a result. And this was a challenge with the legacy messaging system that supported limited throughput. ETL took up to 16 weeks at times. So to solve these problems, Nordea put Kafka at the center, create a parallel offload of data, a parallel stream into Kafka, gradually moved some of the consumer applications over, checked how that is going, and then over a period of time, this will get them ready to move the writes over and perhaps even shut down the legacy system. I want to just mention that this project had a huge impact on Nordea. They were able to reduce platform costs by a huge amount. They were able to drop the turnaround time for analytics from weeks to seconds. And now they're even getting ready to give all their analysts access to KSQL so they can actually analyze and experiment and report on this trade data in real time. So the second option for taking your very first steps into production is producing new streams of events that were previously non-existent or maybe even not possible. The most exciting example that I want to share here of an organization that's doing this is Audi and their connected car initiative. Their vision is to collect event data from the 850 sensors that will live in a car's onboard processor and then pull it into a streaming platform. This will power several functions that are critical to Audi's business. They will be able to identify issues with cars sooner, maybe even reduce cost on repairs. And the most exciting thing is they will be able to alert drivers around hazards, right? To save time, to avoid accidents. Longer term, this data will allow Audi to know how cars behave, how drivers use them. That will in turn inform future product and service offerings. Audi has selected Kafka to be the streaming backbone for the entire Volkswagen group of connected vehicles. So not just Audi, but Porsche and Lamborghini will also be benefiting from this platform. Data will be collected from the cars using MQTT proxies. It will be streamed through the streaming platform into several regional hubs in Germany over the cellular network. Yes, streaming events over the cellular network can be expensive, but Audi believes that the data will be much more valuable than this network cost. And this isn't just Audi. I see this trend across the board in IoT. Here, event-driven architectures, they are the need. They're not a shiny, nice-to-have technology. And they have all sorts of projects that they're putting in place that are producing new streams of events. So as you put more and more applications into production, you move to a stage called mission-critical streaming, right? And capabilities of a streaming platform that really matter in this stage are security and durability. Exactly one's guarantees, ability to never lose a message. Even the ability to monitor event streams across applications and be able to express a data completeness SLA, be able to alert on it. This stage is also about integrated streaming, about breaking silos using Apache Kafka, about fully exploring the stream and table duality, joining streams and tables to integrate data across business units, across silos in real time. You may have heard of ING in their talk yesterday. This is ING's One Bank initiative that they talked about last year. From real-time fraud detection to real-time customer communication, ING now has several mission-critical applications using Kafka that use data in different parts of the bank. For example, for the real-time fraud detection application alone, they built customer 360-degree profiles so that they can do anomaly detection across asset classes, across different geolocations. But then all this did not happen in one go. ING's trust in Kafka has grown over a period of time to a point where today, I'm really excited that what they're doing is they have some experiments in place to move one of the most critical applications in banking over to Kafka, the payments platform. Now, this is still in its early stages, but what mattered to ING before even undertaking this experiment were Kafka's exactly one's guarantees, ability to never lose a message, and the fact that it is battle-tested at scale. So as more and more applications at ING move over to Kafka, they're gradually realizing their one bank vision. I really like what Richard at ING has said is they were active in 40 different countries, but acted like 40 different entities, just sharing profit and loss statements. Kafka is becoming the common thread that is tying the bank together into one unified organization. As you move beyond mission-critical streaming, you enter global streaming. In this stage, your business has grown to a point where you're servicing customers internationally. There's a lot of power in global streaming, but there are several big challenges. Here are some. How do you make data available to applications across wide area networks? How do you serve data efficiently from closer geos? And with things like GDPR, how do you implement data sovereignty rules? And the problem is that the old ways of solving this, they don't cut it anymore, or they're too operationally challenging. We know how this works today. You have a hot standby, you do manual failover that takes hours. You take a global service, you break it into bespoke regional services, and you push all the geo complexity into the application layer. That's not ideal. So the question I want to pose here is, what role can Kafka play to truly enable global streaming? I want to share a thought experiment with everyone. Imagine the ability to deploy a Kafka cluster across wide area networks, where a topic is transparently replicated across a set of regions, where you can write locally, you can read locally or globally. So let's make it a little more concrete. Here's a typical deployment. This is a simple banking application. There are two instances of this application, one in US East, the other in US West. They're both tracking user actions. They're writing events to the same Kafka topic. But now what if you could distinguish the events that originated in US East or US West using, let's say, a namespace qualifier, as you can see on screen? Essentially, what if you could also configure this user actions topic so that no matter where the events were written, they were also globally available and replicated to all the regions? Over time, as you add more and more regions, This gives you leverage. You may have more and more instances of this application across different geo-regions. They're all writing locally so that they don't hurt on latency, but then the topic data is available globally. The nice thing is that here you can support many different consumption patterns, right? You could have some consumer application that just wants access to a particular region's data, like perhaps it's deployed in Europe. You may also deploy, a global fraud detection application in just one of these colos. And then it needs access to the user actions topic that originates in, that has data from everywhere, right? So that you can detect anomalies as a customer moves across different geos. So if this was possible, then our global fraud detection app could just do that by subscribing to the /* namespace for the same topic. Let's not forget data sovereignty. To comply with GDPR, what if you could also specify replication policies at the topic level so that the topic is replicated across different data centers within a single region, let's say within the European region. If that was also possible, then in this case, our fraud detection application now does not get access to data that originated in the European region. Okay, so now this is just a thought experiment, but it's a vision for Kafka I'm really excited about. We have a thriving community and a growing ecosystem. I'm sure we all can get together to really figure out and explore what the world looks like when Kafka is truly global this way. Moving on and coming to the most evolved stage a business can be in on this streaming adoption journey, this is the central nervous system stage. This is the stage your business gets much closer to what I call the digital natives. In this stage, you have a central nervous system. It's powered by a streaming platform, and all the data in the organization is managed through this single streaming platform. The most exciting story of an organization that started from pre-streaming, advanced all the way to central nervous system stage is Royal Bank of Canada. Just a few years ago, they started their streaming journey with option 1 by freeing data from all the legacy mainframes. Today, they have 30+ use cases across 50 different applications, 10 different lines of businesses, all tapping into the streaming platform. It powers everything from their transformation away from monolithic applications to cloud-native microservices. They were also able to reduce the turnaround time for their analytics from weeks to seconds. But the most important thing is they were able to share common data records through, across business units. And not only just that, they were able to share that data with external business partners. Now they have a single source of truth at the heart of their data center. I'm really happy that Kafka is really transforming RBC into a modern event-driven bank. The most interesting takeaway, though, is that all this happened very quickly. Adoption of Kafka at RBC was organic and massive. Within the first few weeks of them taking their first application live, they had 37 different teams asking to use Kafka. That's how you should expect Kafka's adoption to grow in an enterprise. I mentioned the digital natives before. RBC is a story of transformation. There's another type of organization that is in central nervous system stages, and they're the digital natives. The companies that are born digital, so a lot of the data just naturally is expressed as events. The nice thing is that, or the peculiar thing about digital natives is that they advanced to the central nervous system stage very quickly. So Netflix, of course, is a prime example of a digital native using Kafka at massive scale. Today, they have thousands of brokers, and they're processing an astonishing 2+ trillion messages per day. This is a pretty powerful state for a business to be in. The possibilities are immense. We've experienced this before. In this stage, everything happening in the business is an event. It's available instantly to all the applications. The same data that lives in your warehouse is available for stream processing. And the great thing is that all this is possible by also simplifying your data architecture, by deploying a single platform at the heart of your data center, the streaming platform. So as you think about your use of Kafka today, you discuss it with fellow Kafka users, or maybe even you pitch it internally in your organization. See if you can place your organization on some phase in this journey. And then think about how you can help your company, your organization move to the next phase up until the point where it is truly and completely event-driven. I hope to see a lot more organizations up in the central nervous system stage by next summit. I hope you learned something about this streaming adoption journey. Thank you very much.
Yeah, there were a couple really interesting things in there. Global Kafka, that sounds really compelling, and things like the NAV, life as a stream of events. I mean, how long is your topic retention time? 70 years? Maybe 80 if you're lucky. And Neha also talked about Audi, and I'm very pleased to welcome to the stage next Mr. Stefan Bauer. He's head of development for data analytics at Audi Electronic Ventures, and he's going to talk to us about what Audi is doing with cars and Kafka. Welcome to the stage.
So good morning, everybody. I'm very glad being here today, especially after Neha gave us some very exciting insights in the principles of what is data streaming world about, and about events, about streaming, about speed. So we called my speech fast cars in the streaming world. I guess everybody knows that we are building very fast cars, very cool cars, and pretty nice ones, others also. But what we are doing in the streaming world. So I would like to give you insights on the business side about the streaming world and about how could we earn money out of it. Because that's we all here. We want to earn money and we want to use our data for earning money and for giving our enterprises the chance to go ahead and to give the customers more experience about that. So I'll give you then the data-driven world. What is it? We're talking a lot about it. Give you some examples about having the chance to earn money. And then what is the answer of Audi on that? How do we do that? How do we collect the data? Of course, what kind of platform do we use? We are on the Kafka Summit here. Yes, Neha told you about, of course, we're using Kafka for that. And then what is the vision, where we want to go in the future and give the customers exciting experiences? Yeah, well, it's going on. So, the data-driven world, I guess, you know Amazon, of course, and Amazon is doing very well in the data-driven world. It's already using every single data you produce, and they manage it to use this data for increasing the revenue, about roughly 30% annually increase of revenue. That's tremendous, that's amazing. And they are doing it not only because of personalization, but using this personalized data. So use it to give your offers, what are you buying, what they recommend to exactly what you need, and of course, then you're going to buy it, and so they make money out of it, and they use the data-driven world in the streaming world extremely successful. A second example, Neha also mentioned it on a technical way, how much data they use, and they use also the Kafka streaming platform. They use it to find out what we want to see. They use their mentioned here 600 billion data objects a day, and they knew before they even produced the House of Cards that it will be a hit, because they knew that we want to see political dramas, political scenes, and we want to see Kevin Spacey starring in one of those things. So that's what they are doing with this, a lot of data, and they're also very successful in that. We as Audi, we are also part of this data-driven world already. Maybe you don't know, but we already have, we call it Jack. It's an autonomous driving vehicle. Jack is able to, as it says, driving autonomously. And of course, it's still a prototype, but it has the heart of what will be in the future. And Jack is also possible to things like driving a traffic jam or driving with 60 miles per hour, giving you the chance to not to have to conduct your car, but being able to do other things. And Jack is producing lots of data. If you have let's say, average use of a couple of hours a day, you get about 4 terabytes of data of one single car. And imagine we produce only with Audi around 2 million cars per year. In the Volkswagen Group, it's 10 million cars. So we have really to think about how do we use this data, and the data is already here. So what we think, data is in a data-driven world, it's not only the oil. Often mentioned the oil. Of course it's the oil, because this gives you some more flow, some more stream in your daily business. But for me, it's much more the new DNA. Because the DNA gives you the ability to involve your business and to make insights out of the data. Nia mentioned, and Jack yesterday also, Jay, that it's not the data itself. You have to get to events. You have to know what is within the data. You have to know what is the insights out of it. And then you are much more in a DNA world, but only in a raw oil world. And I guess that's what we also believe. Fault-tolerant, our claim, we need data for doing that. We believe that data engineering, and that's what this meant is, that data engineering is giving us the next wave of fault-tolerant. We have to know from the right person, the right device, in the right place, in the right moment, what does this person need, what does it want to have now, and how could we make the experience much better in that specific moment. And for that, of course, we have to do in the fast data streaming architecture, and that's why we're here, and that's why we want to give you much insights in how do we do it. So we call it the Audi data collector world. It exists of different, well, no, come on. No, it's going on. It exists of different parts of a whole system. You saw we have 4 terabytes data for one single car. Of course, it's not possible to transmit all the data. It makes no sense. It's too expensive. We wouldn't never make money out of it. And of course, it's a lot of data which has no use. It's just there. And I don't want to see every millisecond the actual velocity of a single car. Yes, it's there, but I don't need it, usually. So we thought about building up an intelligent Audi data collector. That means we want to get the data we actually need. And the actual need could be in 2 ways. It could be, let's say, a human need. We call it the campaign manager. Campaign is not a marketing campaign, it's a data campaign. To see why we could have some developers in our company that say, I would like to know how my brake system is used in South Africa or in South America, or I want to know what is the behavior of the drivers around Munich or around London. So we can set up a campaign for giving us this data, the cars that are actually driving around in London to see what is the actual behavior with that, not on a personalized thing, but on the car level. And then this car, they will ask our central, we call it MBB, it's modular backend Baukasten. Everybody knows in German here, I hope. So it's a toolkit for managing all this information, for authorizing the cars and telling the single car, hey, for you, there's a new campaign. Please collect from now on, when you are in this area, exactly this data like engine behavior, like brakes behavior, whatever, or even like what is the actual behavior around you, weather conditions, wind conditions, road conditions, a lot of things we can get out of the inside of our cars with these views, or even with our sensoric, Nia showed us already, to see what is around the single car. And this is then sent to our, we call it now AC/DC, so it's not a band, so they will not come on stage. It's only a platform. That is the center and that's the heart of the whole system where we stream and where we analyze these issues, come on to that later, and then we produce the insights out of it. And the insights, again, could go back in a big loop on an automatic way to say, okay, I have thought with the insights could set up not only a human-driven campaign, it could also be an automatic-driven campaign. When we recognize, oh yeah, I have enough information about the weather conditions in London South now, please stop it to all of them. So we can really set up an automatic loop that we really have the intelligence that we really get the data in that moment when we need it, to make it possible for us to make money out of it, of course. Yes, the example for an automatic approach could be, yes, when you're in an unknown city, of course, you always have the same problem where to find a parking lot, a vacant parking lot, of course, not only somewhere in the map you see there's a parking house or on-street parking. Yes, you want to have it where you are, so when you are very close to your final destination, the car will send a request to the backend to say, okay, give me the actual vacant parking lots in that area I want to be. And then the whole machine will start and could start and send out these different campaigns and different data collection requests to the cars that are in the right area in that moment. Say you're collecting it via sensoric, and also we could also include some third-party information about that, like we have it on a here map, for instance. And then we can put it together and send it back to that single car that requested the information. And of course, we could also broadcast the information to other cars around. But that's what we meant. We need it in that moment when the information is needed and requested. And that leads us to a let's say, central insight. Life is not a batch mode. Definitely not. Life is never ever batch mode. You said, Nihar, it's a stream of events. Yes, it's a stream of events, but it's streaming. It's always changing. So with everything is changing all the time, and that's what we need. Then we need real-time approaches and to be able to react in real time. Let's look under the heart of this whole system, under the platform, where we'll be able to get this real-time approach in it. Well, the automotive cloud data collector, that's the name of this AC/DC, so it's not audio alone. Leah mentioned it's also for the whole Volkswagen group. That's why the R is, of course, for automotive. So we're building up the standardized and the reactive platform. This will be very scalable while we are working and reacting, of course, worldwide. So it's not only for one single country. We would need to have that on a global scale. And of course, we have to set up the scaling velocity according to how many cars are using the approach. I don't know how you have your insights, how the car manufacturing is working. So we usually have development cycles of around 5 years for a single car or for a single model. And of course, then we bring up new models every year into the market, different models. And so we have a kind of a ramp up phase, so that we have to be able to ramp up also in the number or volume of cars, and of course in regions and in countries. So we have to do that on a two-side scale up, and for that we need some technologies that is in parallel able to scale up. Otherwise, it would be, of course, again, too expensive to be in advance to say, okay, I have to build up the platform for 10 million cars a year, but I use it only in 5 years. I only have these 10 million cars. In these 5 years, it would be expensive. Nobody will give me the permission to do that. So that's why we need this scalability and, of course, availability. Imagine you are requesting the parking lot and we say, oh, no, we have a downside on the server, so I can't give you that information. I don't think you're very glad about that. So, of course, we need the high availability and, of course, performance. Well, that's quite obvious that we need that. And what we're doing in this platform, we are gathering all the data the car is producing within and around the car. So what are the kind features of that? Real-time analysis. Another example for the real-time analysis, we can identify black eyes on the street and to see, and then this information over this AC/DC platform to all the third parties that have subscribed it. So, and subscription means you get it when you need it. And then you can answer it and you can broadcast it again to all the fleet that is around that specific area. So that means real-time analysis. Again, real-time, it's not a batch thing. We need it real-time. The other issue is what we're doing with that, generating business out of it, using it as a swarm intelligence, we call it. Swarm intelligence means that the cars itself, they are collecting information about the actual surrounding, about what are the lanes marking the roads. Maybe they changed from yesterday, maybe had some street working ahead, so we have to change the lane. Maybe we have new streets or new roads already. We think it's happening all the time. Well, the map producers here, Google, they are all sending these cars around the world and to measure up and to collect the actual data. Our cars, we do that for them in future, as we're able with our sensoric to know exactly what is on the street now. And we need it, and that's much more also for giving us actual and accurate information for our autonomous driving cars, because those cars have to know about what is on the street, what is around the corner, because they only have on their some sensoric about their, they don't see what is behind the corner, they don't see what is behind the hill. So but they have to react, of course, when they're driving with 60, 80, 100 miles, not miles, kilometers per hour around. So it's necessary to know what's behind that, because of course these are machines and they have to know as much information as is possible. And we're trying to gather it. And of course, giving all the information also back to you as a customer. We have, with example, the green waves with changing speed limits all the time. So this is information we have again in real time, and we are able to gather it with all our cars that are outside and those cars, and this information, putting them into events again, and of course, being intelligent enough to send only this information when we need it, and then put it together and send it back via here, for instance, and together with other OEMs, back to the cars that are in the right area, and also building up a very accurate, we call it reality index, that we know exactly what is around you as a car in that specific moment. What we also will have, and that will be one of the first use cases, will be on the market. Imagine you have an electric car, of course. The electric car needs battery power, needs charging stations, and you have some longer journey around. You have to recharge again, and to say, okay, combining also information like where you want to go, what is the final destination, what is your actual route, what is your actual car, how much consumption do you have? That is depending on your behavioring, of course, but also on the weather conditions. If it's cold, if it's warm, maybe you're on a hilly road, then you need, of course, more consumption of power when you go on very straight roads. So all this information we can combine, and we need that also in a very actual way, and because it could change. Imagine you are somewhere in the Alps, and then you decide, I don't want to go the usual way. My Navi suggested to me, just I want to step over a hill because, well, it's fun, whatever. I would like to do that. So then you have to be able to see, okay, is it possible? Recalculate the route that they will be able to go to your final destination. Do we have charging stations there? How do we recharge? How long time does it mean? And is it free? Is it available? And of course, things like reservation, like booking, like payment, always could be done in that real-time events. So this can be things, of course, there's a kind of a predictive intelligence to give you the prediction what will be happening in the next 1, 2, 3, 4 hours. And then we are able to combine also the information and give it back to you as a user of the car. So I talked a lot about the platform. So what is a platform? This AC/DC automotive car data collector, yes, of course, it's combining the car with the back end. What we are using is, yes, also it's called SMAC stack technologies. Of course, Kafka and the Kafka platform itself is one of the key features to be able to handle all the streaming data that are coming in. Nia mentioned already we use the MQTT protocol for doing that. It's built for exactly that. So we see the car as part of the Internet of Things. It's an IoT approach. That is one of the perspectives. So in that approach, we see, okay, it's just like a device, and we have to connect those devices to the rest of the world. The rest of the world, well, we see it here, with the Cassandra as storage, Kafka and Spark as analyzing let's say, library and tooling. From beginning on, we thought we are on a global scale, and of course we have to be able to react very fast and very quickly. As I said, then we really built on a fully cloud-based approach for that, which gives us, of course, the challenge to integrate to the rest of our world. Of course, Audi and Volkswagen Group is not a full cloud-based company. We exist since 100 years. Of course, it's not the case. So we also have to use. It's possible. To get into integration of the backend. We already exist. There are different platforms, of course, evolving. We are concentrating with our platform on the car data, which are generated with the cars. Of course, we have platforms that are focusing on data that is generated by you as a customer on a website, on an app, when you're talking to your dealer, when you are in a workshop, whatever. So there are different sources of information we have to combine in the company. And for that, we also use this Kafka for connecting with things, so that we have this Kafka connection sometimes, and then we really have to get this information from our legacy systems or even third-party systems to combine it with the information we have in the central platform, in the ACC platform. So that's our approach on doing that. Well, this platform will go live this year, first time. We will go live with our fully electric car in September. Fortunately, not allowed to show you the picture today. It will be released soon. So this is nothing in future. So it's real. It's here, and we're going live very, very soon. Yeah, I mentioned our method, Kafka. What do we with Kafka? Of course, it's our message broker, it's our platform for integrating and for handling, and of course for scaling. I guess all of you know more about that Kafka, and of course we are here for much more questions to go deeper in that issue. So, what is then the vision behind this everything? I told you I'm coming here, fast cars in the streaming world, the business approach. What we want to do, we want to give you time back as a customer. So that's our vision, creating customer experience around our cars. And of course, one of the cars will definitely be autonomous driving cars. And for those, giving you, we call it the 25th hour of a day. Imagine usually on average, you use 50 minutes per hour. 50 minutes you are using a car every day, all around the world. That's one of the average time. So this hour we want to give you back. We want to give you back with some experience time, where you can do some more, whatever we call it, quality time, productive time, downtime for your family. And for this, we need, of course, an accurate information about that. And because you want to get a very good time in this car. And of course, a car, if it's an autonomous car, should drive very safe. And for that, of course, we also need all this information about the map, about the surrounding, about the conditions, about even the condition of the car itself, to be able to react in some matters, and then give you the ability to use this time for you as you want to do. Maybe if we go back to a downtime for entertainment, that we have whatever, we don't have it now, but it's in imagination, together with an Netflix or Spotify, to give you an exact that entertainment what you would like have in that moment. Maybe it's different when you're driving the car, or if you're sitting in your living room. And of course, it depends on how much time do you still have. If it's only 25 minutes, or you have 1.5 hours left, so it could be different to that. And then we can really react in a real-time world. And that's, I guess, our most, let's say, important approach. It's a real-time world, connecting information in real time, getting all the events that we are able to do, and then we can create custom experience so that we will be able to make money out of our data and out of our experience, imagination we have. So that's our vision behind it, driving our company in the data-driven world, and that means we will give you back experience, and some of them we showed you today. the platform also showed. If you have more questions, come out to our booth, ask the questions. We can give you some more insights, of course. And of course, we accept also application forms because we always need people for doing that. Yeah, so thank you for your attention. I'm glad to be here.